Hello, PLP Geometry. Welcome to video number 7B. So we're still talking about, I'm not going to do the whole Unit 4. So we're still talking about number 7 of Unit 4, but this is the B video. And again, we're still focused on trigonometric ratios. Trigonometric ratios. Okay, and this is your example video, right? I'm going to have you do a mini lesson with me after this because trig ratios are that important, in my opinion. And I want to make sure that we're on the same page. But here are 4 examples of the problems you will see using trig ratios. All right, so the first example here, I'll do it in red. Okay. Identify the trig ratios for angle U. And here's our picture. We have a right triangle. Always have to have a right triangle. It's going to be triangle U, or I should, STU, sorry, STU, if I go in alphabetical order, right? T being the right angle, and then we have a 15 here, a 20 here, and a 25 here. Okay, so first and foremost, right, we want to focus on angle U, which is right here. So this is where I draw that arc inside the angle, draw that arrow inside. That arrow is pointing to the opposite side. Remember, our SOHCAHTOA. We need the opposite, hypotenuse, and adjacent. So the 20 is going to be the opposite. The 25, the longest side, is the hypotenuse. And the third side, the one next to you, is the adjacent. Okay, and now we simply use our SOHCAHTOA to create our 3 ratios. So sine, S-I-N, lowercase, sine of U equals. So we're looking for opposite over hypotenuse, O over H. So the opposite would be 20, the H would be 25. Now you need to type this fraction into Desmos, Ohio, and get the simplified version of that fraction and or the decimal, depending on what the problem is asking for. So if you divide this in the calculator, you are going to get a decimal, 0.8. If you press the fraction button, it'll simplify it to 4/5. So this is the simplified ratio of the sine of U. Now, I have not done a very good job of connecting this to similarity. The reason why this right triangle stuff is in the similarity unit is because these ratios, 20 over 25, 4 over 5, all trigonometry is its ratios of similar right triangles. That's all it is, right? And again, we'll even talk about that more in the next problem, okay? But that's what we're doing here. Okay, cosine of U. Okay, cosine is adjacent over hypotenuse. The adjacent is 15. The hypotenuse is 25. Again, type that in the calculator. You'll get a decimal of 0.6. If you press the fraction button, you'll get 3/5. And then last but not least is the tangent of U. So tangent is opposite over adjacent. So U is here. Opposite is 20 over adjacent is 15. If you type in the calculator, you're going to get 1.3 repeated. Just make sure you round to whatever it's say to round to. If you press the fraction button, that'll give you 4/3. And there are the 3 trig ratios for angle U in this right triangle. Okay. Now notice here, I never typed sine, cosine, or tangent into the calculator. Never did that. So understand when it says identify the trig ratios, you're just finding the fraction or the decimal version of that fraction. Okay. Now let's get into actually using the calculator. Okay. All right. Example 2 here. Okay. So we're going to find x. And here's our picture. We have a right triangle. Undo that. Oh, sorry about that. Okay, here's our right angle. This angle is 73 degrees right there. It is triangle ABC. B is the right angle, and our X is right here. Okay. So we need to find the value of X. So notice in this picture, we have a right triangle with one angle given. And we also know that this is 9.9, sorry. And one side given. So we can use trig to solve this. We cannot use Pythagorean theorem. We cannot use special right triangles. We have to use trig, okay? So before I start, what I would do is I would write down my SOHCAHTOA, right? SOHCAHTOA. I'm going to work down so I can maybe keep this on. Never mind. Okay, SOHCAHTOA. Right, now, in this picture, we're given the 73-degree angle. We're given this angle. I'm going to put an arc around it. You can circle this C if you want to. Draw an arrow. That arrow is pointing to X. So in this picture, the opposite side is my X. This AC across the right angle, this is the hypotenuse. And then the 9.9 is the adjacent. Now, sometimes it is hard to identify the opposite and the hypotenuse. So again, whatever angle you're looking for or given, draw that arc, draw that arrow, it points to the opposite side. Now notice, when you do these trig ratios, we only need to use one of these, SOHCAH or TOA. And the way we figure that out is we look at our picture and we say, hey, what side do we either not know? Well, I'm sorry, what side don't we need to use, right? In this picture, we know the adjacent is 9.9. We want to find the opposite as X. So we don't really care about the hypotenuse. I'm going to cross it off. And if I don't care about the hypotenuse, I'm going to cross off the two that involve H in SOHCAHTOA. And that'd be SO and KA. This is a TOA problem, and TOA stands for tangent. So we're going to find X by using the tangent. So we're going to say tangent. Now, of my angle, now I'm not going to use capital C because I need the number, and they give me the number, it's 73 degrees. Tangent of 73 degrees equals, and now we're going to put the opposite over the adjacent. The opposite is X over the adjacent, which is 9.9. Okay. Now, when you do this, you should only have one unknown, and my X is right there. Okay. So now, how are we going to solve this for X? Well, I see a fraction on the right-hand side. To get rid of this fraction, we're going to multiply by its denominator. This is the first step in any of these problems. Once you set up the equation, we're going to multiply both sides by this denominator. So times 9.9. Let me do this in a different color. Do it in purple. Times 9.9 times 9.9. And now what's going to happen is over here, the 9.9's cancel. X is by itself. This right here, and I'm going to rewrite it right here, 9.9, you can put the times or just write it next to it. 9.9 tangent 73 degrees. This is what we're going to type into Desmos to get our answer. In the calculator, the tangent of 73 degrees is a stored value. It is a ratio. And like I said, it's about similar right triangles. So no matter what size your right triangle is, if it has a 73-degree angle, then the opposite and adjacent have the same ratio. Because again, similar triangles, sides are proportional. And again, I know it's a big idea. I'm not doing a very good job explaining it, but for our purposes, it's based off similarity. But now we just have to type this in Desmos. So 9.9 tangent of 73 degrees. So let me show you how to do this. Okay, so I'm in Desmos, right? Now, the first thing to make sure you do is over here on the wrench. You need to make sure this word degrees is white and it's dark behind it. You are not there, and some of you maybe never will be there. It's okay. But we also measure angles in radians. But for our class, it's degrees. So here we're going to type in 9.9. Now, to get tangent, I'm going to type in TAN. Notice it goes from being italicized to then solid. Now, you can put a parenthesis or you don't have to. I'm not going to. I'm just going to put 73. And boom, there is the answer. It wants it rounded, I think, to the nearest tenth. So without rounding, X would be 32.38. I'm going to round to the 3, so I look at the 8. The 8 is above 5, so it rounds the 3 up to a 4. So our value of X here was 32.4. And that is how we use trigonometry to find missing side lengths. If you look at your picture, right, That side is bigger than 9.9. It's a little bit longer, right? So it makes sense a little bit bigger. Okay, let's do one more of those. Okay, let's go back to this guy. Okay, another example. Sorry, let me make my, I don't like how it always resets it to a thick. Okay, so now we're going to find x again. Okay, different picture. There's my right triangle. Here's my right angle. This is triangle RST, S being the right angle. I'm giving you a 20-degree angle right here. I'm giving you 9.3 as this side length here, and I'm giving you x right there. Okay, so I approach the problem exact same way. SOHCAHTOA. So, ka, toa. They give me 20 degrees. I'm going to put an arc there. I can circle the T if I want to. Draw that arrow in. That means that side RS is my opposite. The hypotenuse is over here where x is. X is the hypotenuse. And then 9.3 is the adjacent. I look at my three sides. Which one don't I care about? That would be the opposite. I could care less. So in my SOHCAHTOA, cross off the O's. That leaves you with ka. This is a cosine problem. So we do cosine of our angle. Our angle is 20 degrees. Equals. It's the adjacent side. The adjacent side is 9.3 over our hypotenuse, which is x. So this is the equation we need to set up. Okay, same thing. It should only have one variable. Here's my one variable. We're going to start the problem off exactly the same way we did last time. We're going to multiply by the denominator of the fraction. Now, the unfortunate part here is the following, right? The x's do cancel, but now notice x is not by itself. It says x times the cosine of 20 degrees equals 9.3. We need to get x by itself. Well, if x is multiplying with the cosine of 20 degrees, and the cosine of 20 degrees is a number itself, we're going to go ahead and divide both sides by the cosine of 20 degrees. The cosines of 20 degrees cancel here. X is by itself. And now on the right-hand side, we get 9.3 divided by the cosine of 20 degrees. And this is what you're going to type into Desmos to get the value of x. It's a division problem this time. Okay. Now notice that x is the hypotenuse, so I'm expecting a side length bigger than 9.3 as my answer. So let's see what happens. Okay. Okay. So I'm still in degree mode. All right. So I got to type in 9.3 divided by, right? I can use the question mark slash divided by cosine 20. And there I go. Again, round to the nearest tenth. So x is going to be, looks like 9.89, round to the 8. The 9 rounds the 8 up to a 9. So our value of x is 9.9. Again, a little bit bigger than 9.3. Hypotenuse is the longest side. Perfect. Okay, last thing here. Now, before we go into the problem, so those were both examples where I gave you an angle and a side, right? So now, what if I give you two sides, right? Well, there's also, and we'll do this in blue, there's also this idea called inverse trig. Now you've used inverses all your life, adding, subtracting your inverses, multiply, dividing your inverses, squared and square root inverses. So for trigonometry, if I want to find an angle measure, if I want to find one of the acute angles in the right triangle, I'm going to use inverse sine, inverse cosine, or inverse tangent. And all it is notation. It's the sine with a -1 exponent, cosine -1 exponent, tangent -1 exponent. Again, it just goes in the exponent spot. It's just notation. Okay. All right, so let's take a look at how we would use this idea in a problem. So example here, okay? Again, it's going to say find x. Here's our triangle. Okay. And this is triangle JKL. J, K is the right angle, and L. So they called angle L x degrees. They labeled this side right here as 87 and this side as 57. Okay, so we'll start this problem off just like all the other ones. So, ka, toa. Now the one thing to identify is that our angle is the unknown. So right here, x is an angle. What this means is you're going to use an inverse to solve this problem. So that's something you should identify at the very beginning of the problem. If I see I'm looking for an angle measure, it's inverse trigonometry. Now, we start the problem off the same way we do all the other problems, right? So here's my angle. So 57 is my opposite. 87 is the hypotenuse. That means the third side, LK, is my adjacent. Now I cross off the side I don't care about. I don't care about the adjacent in this situation. So I'm going to cross off the two involving A's. That means that sine is my problem. So sine, now my angle is x. So sine of x degrees equals, and I put the opposite, 57, over the hypotenuse, 87. And now, here is where we're going to apply the inverse sign. What we're going to do here is I'm just going to put a big parenthesis around this. Right? Notice like there'd be no reason to multiply by 87 because the x is over here, right? We just want to get the x by itself. Well, in order to get rid of sine, we can't just divide by sine. We're going to take the inverse sign. What happens is the inverse sign and the sign cancel, and we do get x. But then on this right-hand side, we take the inverse sign, and now I do put this in parentheses, of this fraction, 57 over 87. This is what we're going to type into Desmos to get our angle measure. So again, it's very important that you're in degree mode in Desmos. Okay, so let's do this together. Okay. So again, if you just want to double check real fast, right? Degrees, we're good. Okay. So we're going to do sine and then the exponent button. Whether you do the shift 6 or AB button, I don't care. Arrow to the right to get back down. And then here's my parenthesis. And I'm going to put that fraction in the parenthesis. It was 57 divided by 87. Okay. And this is going to be my angle measure right there. So the value of x, rounding there is 10th, is going to be 40.93. The 3 does not round the 9 up, so your value of x is 40.9. And when you know x is an angle measure, I love you to put the degree symbol with it. 40.9 degrees. Okay. So trig ratios. I know it's some heavy stuff, right? I think it's really interesting because you connect angles and sides. We will do a mini lesson. So come talk to me. Let me know you're done with these 2 videos, and I'll make sure you know what you're doing. Okay. Thanks for watching.